All right, greetings everyone. Welcome to the second video for section 3.5. We're going to finish up this section that relates specifically to derivatives of trigonometric functions. And in the last video, remember that we found the derivatives of sine, cosine, and tangent. Now we'll look at finding the derivatives of some other trig functions. Okay, so hopefully you remember from either Math 142 or your previous math class or wherever you took some sort of trig, these other trig functions, cosecant, secant, and cotangent. Hopefully you remember that they are all related to sine, cosine, and tangent. So we may just start by reviewing that really quickly. So remember, cosecant of x is equal to 1 over sine of x. Secant is equal to 1 over cosine. And cotangent, there's a couple of different ways to think about cotangent. We can think of it as 1 over tangent, or not sine over cosine, but cosine over sine. Hopefully that one makes sense, because remember, tangent is sine over cosine, so cotangent, if it's 1 over tangent, it would be the reciprocal of that. Okay, and those end up being useful when we need to find the derivatives of each of these. So let's first look at finding the derivative of cosecant. Now, we could try to do like we did with sine and cosine, draw the graph of cosecant and draw some tangent lines, but as you can imagine, that's going to get really sloppy. So instead, we're going to use the fact that cosecant, another way to write that, is 1 over sine. Okay. And notice that when we do this, now we're finding the derivative of a quotient of two things being divided. So to find our derivative of cosecant, we can just use our quotient rule. So we can do the bottom, which is sine, times the derivative of the top. So derivative of 1, that's a constant, so the derivative is 0, minus the top, the top, times the derivative of the bottom, which, remember, the derivative of sine is cosine. And then we'll divide by the bottom squared. So remember our low d high minus high d low, square the bottom, and there you go. So we're just doing that there. And then we can simplify on the top, so we'll have sine of x times 0. That's just 0. Then negative 1 times cosine will give us negative cosine of x. And then we'll have sine squared of x on the bottom. So our derivative of cosecant has come out to be negative cosine over sine squared. Now, as you might imagine, that can be rewritten in a little simpler form. So let me do this, clear that out. And so we were at negative cosine x over sine squared. And another way to write this, especially since we have the sine squared on the bottom, would be negative cosine of x over sine of x times 1 over sine of x. Because notice if we multiplied this back out, 1 times negative cosine gives us negative cosine sine of x times sine of x on the denominators gives us sine squared. And then negative cosine over sine gives us negative cotangent. And then 1 over sine gives us cosecant. And there now we have the derivative of cosecant. It's negative cotangent times cosecant, which might seem a little strange because we started with cosecant and we ended up with cosecant in our answer. But that's okay. That's allowed. Remember, like the derivative of e to the x is e to the x. So there we go. There's that one. You might also see this written in the opposite order, negative cosecant times cotangent. Those are equivalent. All right. Now, just like I mentioned with the derivative of tangent, if you stopped me on the street and said, hey, Cody, what's the derivative of cosecant? And you wanted me to answer you in 2 seconds, I would not be able to do that. I do not have this one memorized. What I do know is that cosecant is 1 over sine. And if I want to find the derivative of that, I can use the quotient rule. So this isn't necessarily one you have to memorize. You can use the derivatives of sine and cosine, as well as your identities to figure this out. Okay. Now, The derivatives of secant and cotangent can be done similarly. We can rewrite secant as 1 over cosine and then take the derivative. And then we can rewrite cotangent as cosine over sine and take the derivative. So I'm not going to go through all of that right now. You can do that on your own. But when you do that, for the derivative of secant, we get tangent times secant. Okay, which maybe isn't too surprising since cosecant showed up in the derivative of cosecant. And then for cotangent, we end up with negative cosecant squared. Okay, so those are the derivatives there. And again, you guys can go through and double check those yourselves. All right. So let's look at using some of these derivatives of trigonometric functions and some other problems. So here we have to find the derivative of sine of x plus 4x to the 7th plus 6e to the x. And hopefully you notice this is going to use several of our derivative rules. So we have a sine, 4x to the 7th, 6e to the x. So if we go through and take the derivative of each of those, so the derivative of sine, remember, is cosine. And I should have actually said, remember, when you have a bunch of stuff being added or subtracted, you can take the derivative separately. So our derivative of sine is cosine, plus to take the derivative of 4x to the 7th, we use our power rule. So we bring down the 7, multiply it by the 4 to get 28, and subtract 1 from the exponent, so 28x to the 6th. Plus, when we do 6e to the x, we can use this, leave the 6 out front, take the derivative of e to the x, but we know that's just e to the x. So our derivative here is cosine plus 28x to the 6th plus 6e to the x. All right. Now this bottom one, we have sine of x plus 2 divided by cosine. So we have two things being divided. So we're again going to make use of our quotient rule. So our low d high minus high d low, square the bottom and off you go. So the bottom function would be cosine times the derivative of the top, which would take the derivative of both sine of x and 2. You know, the derivative of sine of x is cosine. The derivative of 2 is 0 because it's a constant. So this will become just cosine of x. Then we're going to subtract the top, so sine of x plus 2, and this would be one of those cases we're going to make sure you put that in parentheses. If you don't, it looks like it's just minus sine of x plus 2. That's not what's going on here. It needs to be sine of x plus 2 in parentheses. Times the derivative of the bottom, which if we do that, the derivative of cosine is negative sine. Okay, and also put that in parentheses. Divided by the bottom, cosine of x squared. Okay, and I knew I was probably going to need more room, and I didn't give it to myself. So here's what we can do from here. So we'll multiply out the cosine and the cosine, distribute the negative sign through to here, and then take what we get here and multiply it by the negative sign. So I'm going to skip some steps there, and I apologize, but it's just lack of space here. If we do that, we'd end up with cosine squared of x plus sine squared of x, and then we'd have a plus 2 sine of x. And this is all still over cosine squared. And then here we have cosine squared plus sine squared. Remember, that's our Pythagorean identity, so that's the same as 1 plus 2 sine of x, all divided by cosine squared of x. And we could leave it like this, or notice because the stuff on the top is being added, we can break this apart into 1 over cosine squared of x plus 2 times sine of x over cosine squared of x. Okay, so just taking that fraction and breaking it into 2 parts, and I'm sorry that this is getting really sloppy. But if we do that, Then we end up with, as our derivative here, secant squared of x plus 2 times cotangent of x times secant of x. And we could have left it back again with that 1 plus 2, what did we have? 1 plus 2 sine of x, which I just realized means I made a mistake here. This should be not cotangent, but tangent of x secant of x. Because of that, we'd have sine over cosine. Yeah, that's tangent. So again, we could have left this as 1 plus 2 sine x over cosine squared, or what we have here is fine as well. All right. Okay, one more really fun problem. So here, they want us to find the derivative, and notice what we've got going on here. We have functions being multiplied, but notice how many we have. We have 4x sine x and cosine x, so that's 3 functions. But our product rule only deals with 2, right? So how might we face this? Well, one thing we can do is still break this into 2 functions, just have one of our 2 functions be a couple combined. So I'm going to call this first function here 4x sine of x, that's going to be like my h, and the cosine of x would be k. And then to find our derivative, f prime, well, we do h, which is 4x sine of x, times the derivative of k, which the derivative of cosine of x is negative sine x, plus now the second function, cosine of x, times, now we take the derivative of 4x sine of x. But notice 4x sine of x is 2 functions being multiplied together. So how are we going to find the derivative there? Right, we're going to do the product rule while on the inside of already doing the product rule. Oh, sweet. Okay, so up here I'm going to do some scratch words. So if my function is h of x and we're doing 4x times sine of x, okay, well our derivative, we're going to have to do some product rule here. So we do 4x times the derivative of sine of x, which is cosine of x, plus sine of x times the derivative of 4x, which is just 4. So up there now we have our derivative of 4x sine of x. So we'd multiply that by this cosine x here. So we'd have 4x cosine of x plus 4 times sine of x. And holy buckets, this is starting to get a little messy, right? And then let's see, over here we can distribute. And we can also multiply this out. And if we do that, it looks like we'd have negative 4x sine squared of x plus the 4x cosine squared of x plus 4 sine x times cosine x. Sorry, that's getting crammed over there. Okay, and we can leave it as this, which I know it's a mess. Here, let me rewrite it. So far what we've got is that f prime equals, so we had negative 4x sine squared of x plus 4x times cosine squared of x plus 4 times sine of x times cosine of x. And notice in these middle terms here, right? The negative 4x sine squared x and 4x cosine squared x, they both have 4x in common. So we can multiply out a 4x, or sorry, factor out a 4x. And if we do that, we'll end up with negative sine squared x plus cosine squared x, which may not look familiar right away, but some of you may recognize that. From Math 142, we had a identity for cosine squared x minus sine squared x, which you may recognize is the same as the thing in green down below, which this is equal to cosine of 2x So then we can rewrite this thing as 4x times cosine of 2x plus 4 times sine of x times cosine of x. Whew. All right. Good times, right? Good times. So the moral of the story there is you can have as many functions multiplied together as you want to use the product rule. You just might along the way have to do some mini product rules like we did here. So again, we were going to find the derivative of 4x sine of x. We had to use a product rule there while we were already using the product rule to do 4x sine of x times cosine of x. Okay? All right, that's it for section 3.5. Thanks for watching.